this video, we're going to look at evaluating logarithms, and this is going to be closely related to the last video I put up, which was going from logarithmic form to exponential form. So be sure to check that out if you haven't already, because I'm going to reference a lot of things from that video. Also, if you like this video, be sure to like it, subscribe, share it with someone. So anyway, let's continue. So we're going to look at evaluating logarithms. Now, to do this, we have some basic examples and we have some more difficult examples. Also, depending on the calculator you have will depend on some of these steps, but I'm going to do this just like you have the run-of-the-mill calculator, okay? You can reach out or comment if you want a better way to do this depending on your calculator, and I can give you that info. But for this video, I'm going to show it without the calculator for the most part. All right, so now the first thing we want to go over is this. Before we dive into all of this, let's just first look at log base 10 of x and what that turns into. Now, if I gave you the variable x, you would tell me, well, there's a coefficient here that's understood to be 1. Okay, now, if I were to give you a log, and I just said log of x, there's an understood base there of 10. So if I give you log base 10 of x, well, we could just rewrite that as log of x. Okay, like once again, I'll show you another example. We'll use numbers. Let's say I wanted you to do, let's see, log base 10 of 5. You could rewrite that as just log of 5. Okay, so if you just see a logarithm with no base, it's understood that the base is 10. Okay, so this is the understood, well, if I can spell, that would be nice. Understood base. All right, so now that's going to be related, but now let's look at evaluating logarithms. Okay, that's what we came to see. So let's see it. Now, in the last video, I talked a little bit about this, but let's start off with a basic example. Log base 7 of 49. And what would that be equal to? Well, for consistency, let's make that equal to x, because when we did logarithmic form, we said that's log base b of a equals x. So let's just say this is equal to x. That way we can figure out what x is. Okay? So when you're trying to evaluate a logarithm, essentially what you're doing is this. You're rewriting it in exponential form, and I guess you could do it if you're in your head if you want, but like if you were to plug this into the calculator, here's what the calculator's doing. The calculator's saying, okay, which obviously it does it a lot faster than humans, but it's going to say, okay, 7 to the x power equals 49, because that would be rewriting this in logarithmic form or in exponential form. So then the calculator is basically just saying, well, what does this exponent have to be to make this true? And x would have to equal 2. Therefore, log base 7 of 49 is equal to 2. So essentially, when you're doing a logarithm, you're taking the base and you're asking, well, what would the power of that base have to be to get this number right beside it? Okay, so that's what you do when you evaluate a logarithm. So let's do a couple of easy problems, just so you can see. If you learn to rewrite it like this, you never really need a calculator, and some people can just do it in their head. So let's say I gave you log base 3 of 27, and I want to know what that's equal to. Well, first, you want to set this equal to x, and then you want to rewrite this in exponential form. 3 to the x equals 27. So now your job is just to eyeball this and say, okay, well, what is x? What does x have to be to make this true? Well, 3 to the third power is 27, so x equals 3, which means log base 3 of 27 is 3. And once again, some people will get to a point, which I'm hoping you do because it's just helpful. You'll get to a point where you'll just get this. Like, let's do a brand new one, and I'll try to explain what I mean. Like if I give you log base 2 of 64, and I say, hey, evaluate that. Some of you are going to get to a point where you can go, okay, I remember doing this. I can say, okay, 2 to what power gives me 64? And then you can just answer the question like that. But if you don't get there, that's fine. You can always just rewrite this in exponential form. 2 to the x, which once again we can set this equal to x. 2 to the x equals 64. So then what would 64 have to be? Well, or what would the exponent have to be to give us 64? And x would have to equal 6. So there we go. It's that simple. Now, here is where things get more difficult. All right, and actually, let's do this. I'll give you one more just to practice. Let's say log base 12 of 1. What would that be equal to? So why don't we try one real quick? All right, so once again, you could do this in your head, but let's just act like you couldn't. Let's rewrite this in exponential form. 12 to the x equals 1. Well, anything to a certain power is always equal to 1, and that would be x to the 0. Well, 12 to the 0 or anything to the 0 power is 1. So there's another example. So now let's make it a little bit more difficult. Let's say I gave you log of 16 of 64, or log base 16 of 64 equals something. Evaluate that. Well, this gets a little bit trickier. Because if I just tried to eyeball this and say, okay, 16 to what power gives me 64? Off the top of my head, I don't really know what that would be, so let's write it out. 16, once again, let's call this x. Let's set this equal to x. 16 to the x equals 64. So now we can get a pretty clear picture of, all right, I need this exponent to give me 16 to a power to give me 64. Well, I would think, okay, 16 to the first, that's 16. 16 to the second, well, that's 256. There's an issue. 64 is right in between 16 and 256, which means 16 to the x power is going to have to be a number in between 1 and 2. And the issue with that is I'm going to have to think of a decimal or a fraction to figure that out. And most people, especially when you get into complicated problems, aren't going to be able to just eyeball 16 to the, 1.3 power to give me 64. That's not really something we can do in our heads. So what we can do is we can use something called the change of base formula. So let me get rid of all this. Hopefully that makes sense as to why we need to do this. So change of base formula. Okay. Now, here's why we want to change the base. Most calculators, at least while you're learning this, you should be learning this in like Algebra 1, Algebra 2. Most calculators that you're either given or that your teachers tell you to buy probably don't have a way, or maybe your teacher doesn't want you to know that it has a way, to substitute in this base 16. Okay. Most calculators have a button that just says log. And when you press that log button, it will say log, and then it will say parentheses. And there's no base here for the logarithm. But we just learned the understood base for that logarithm is 10. So essentially your calculator, not all calculators, but a lot of times teachers want you to use the calculator this way. Your calculator is only going to use a log with a base 10. So our job is to try to change our problem so that we have everything as a base 10. Okay? Now, like I said in the previous video, just leave a comment if you want me to make a video, or maybe just comment back to you and explain to you how to plug this fully into the calculator. I can do that. But yeah, like I said, just leave me a comment if you want that. So, change of base formula looks like this. We say log of A over log of B. All right, now, where did we get A and B? Well, the same place we got A and B from rewriting logarithmic to exponential form. If we say log base B of A, well, here's B, and then there's A. We're going to take that and transfer it or convert it into log of A on the top divided by log of B on the bottom. So now let's go back to our problem we just had, which was log base 16 of 64. Okay, we already established that we weren't going to be able to just eyeball this and figure out what x is. So now let's try this change of base formula. We're going to say log of a, so which one is a? Is it 64, 16? It would be 64, over log of b, which is 16. Now, you're going to plug this into your calculator. So just pay attention to this part when you're plugging in the calculator. You will type in log, or you'll hit the log button, and it will open a parentheses. You're going to plug in 64, type 64, but make sure you end this parentheses. Okay? Then you're going to hit your divide button, then log, it will open up another parentheses, then you'll put in 16, and it should give you 1.5. Now, I don't know if I would have thought to guess 1.5 when we first did this problem. So you can see that this is a better way to get the answer rather than just trying to guess numbers. Okay, let's do another one just so you can see. So you can even try this one if you want. We have log base 8 of 32. All right, now if you want to try this in your head, you could say, well, 8 to the x power equals 32. So what does x have to be to make this true? Well, 8 to the first is 8. 8 to the second is 64. We just skipped right over 32 again. So we're going to have another fraction or decimal as our exponent. So instead of doing all that, what we can do is use the change of base formula. So we can say log of a over log of b. And then your job is to figure out what a and b is. So a is going to be 32, and then b is going to be 8. And let's see, when we plug that into the calculator, you should end up with 1.6 repeating. Once again, if you would have asked me to guess an exponent, I probably wouldn't have said 1.6 repeating, and I doubt you would have either. All right, so that's why this is super useful. We can pretty much do any logarithm like this. And once again, if you want me to show you a better way to do it with a calculator, just comment, let me know, and I can make a video over that. So let's do one more, and then we'll be done. So let's try log base 4 of 136 and evaluate that. So once again, let's just say we wanted to try to shortcut this. 4 to the x equals 136. What would x have to be? Well, to be honest with you, I have no idea. I know that it probably has to be in between 3 and 4, I would guess. But let's do this, since we can't think of it immediately. Let's just try to do the change of base formula, which means we say log of a, which is 136, divided by log of b, which is 4. Let's just put that in the calculator, and it should give us the answer. So the answer ends up being 3.5437, and it probably keeps going. Now, I would probably round this to 1 or 2 decimal places. I'll just say it's about 3.5. Okay? Now, once again, how many of you would have thought the decimal is going to be 3.5437 and continuing? No one. All right, so that's why this change of base is so useful. And the change of base also allows you to do this with any calculator. You might even be using your iPhone calculator. You could still probably do this. All right, now that will be where we end this. Once again, you can do this. You could plug log base 4 of 136 in your calculator. If you have like a TI-83, TI-84, TI Inspire, there's Casios that will do this. There are calculators that will do it like this. But if you learn change of base, you can do it no matter what calculator you have, which is why this is so important. So once again, just remember, I would do this. I would just get in this habit. If you get a logarithm, like log base 5 of, I don't know, log base 5 of 10. The first thing I would try to do before I even use the calculator is say, okay, this is 5 to the x power equals 10, and just try to figure it out from there. And if you get a problem like this where you can't figure it out, that's where you can use the change of base and say, okay, log of 10 over log of 5, and then use your calculator. But I would start off trying it this way just because a lot of times the more basic examples you can just do without even needing the calculator.